Hi everyone. Right now I'm at the machine shop here at Parkland College in Champaign, Illinois, and I just wanted to do a video showing the milling machine anatomy for my students here at Parkland. Now of course there's probably a lot of people out there who are wondering what all these controls do on the milling machine. So if you're one of my regular viewers, please stick around. It's not just for my students. The first part I want to talk about is the head. And the head contains the motor, the drive belts, the spindle, and all of the speed change gearing. I should point out that there are actually two different types of heads. We have the variable speed head, and then there's the step pulley head. Now, as I mentioned, there are two different types of heads on Bridgeport milling machines and all the different clones that are out there. And actually from here down, the two heads are identical. For now, I want to point out one of the most common mistakes with variable speed heads, and that is this handle. They put this warning on the side not to turn this handle unless the motor is actually running. And unfortunately, when you're standing in front of the machine, you can't see that warning. So there are people who get up here and they start cranking this handle, and that can actually damage the inner workings of the machine. I won't get into too much detail on how the variable speed head works, but there are two split sheaves, one in the front, one in the back, a very wide, thick belt in there, and then this mechanism, which has a short length of roller chain there, that when you turn the handle, spreads out one of the sheaves, and then the belt moves into a new position and changes the speed of the spindle. Depending on how old the machine is, there are different displays on what your speed is. But in this case, there's a low range window and a high range window. And when you turn the handle, the wheel inside moves and it points to a new speed. In this case, I'm in high range and I'm pointing to around 1700 RPM. Just by turning the handle, I've slowed it down to 1200. And I've just sped it up to 3000. The range on the low range is 60 to 500 RPM. The range on the high range is 500 to 4200 RPM. These are the ranges for US machines, which run on 60 Hertz. If you're in Europe and you're running on 50 Hertz, the speed range is going to be slightly slower. On the variable speed heads, if you want to change from high to low gear, you have this handle on the side. You push it in and you push it all the way to the back, and now we should be in low range. And the spindle's moving considerably slower. There's also a neutral setting on this handle, and that is on the bottom, slightly towards the front. And in the neutral setting, you can turn the spindle by hand very easily. And this is handy when you're trying to sweep in the head or indicate a bore. If that handle is not in the neutral setting when you're trying to turn the spindle, it does not want to move freely. Many times when you're going to high range, it does not want to actually pop in, so you have to loosen the handle and then turn the spindle by hand until it pops in. All of the step pulley machines that we have in the Parkland College shop actually have been retrofitted to have a variable frequency drive on them, and the motor's been replaced, the back pulley's been replaced, and you have variable speed with this knob. I do have a video up that shows how to change speeds on a regular step pulley, so if you need to know that, check out that video. As far as these machines go, you still have a high and low range. There's a sensor up here that tells which position this handle is in for high and low. These now have a range of 50 to 500 RPM in the low range and 500 to 5000 in the high range. You have a forward and reverse switch here. Your knob for changing speeds, and you have an emergency stop as well. There's also a calculator for determining what your speed should be. You hit the manual button, you can change your SFM. We'll put it at 150 SFM, and then tell you what tool size it is. And it sets your RPM for you. If you want to change from high to low range, it's the exact same steps as a regular step pulley machine. The very first thing you have to do is take this handle and move it to the side, and then move your spindle pulley while you move this to the in position, this handle back here. They do have directions right here, and they label these handles A and B. When you want to go from low to high range, you have to move this back to the front, and this is where people screw up. You need to move the spindle pulley until it drops in, just like that. Then you move this handle to the out position. When you feel that spindle pulley drop down, it's actually engaging the pulley with the actual spindle in a clutch arrangement, kind of like this, just like the knee handle. If you skip that step and turn the machine on without dropping that spindle pulley down, you get this incredibly loud grinding noise that's very embarrassing. From here down, the two types of heads are actually identical. They have all of the same controls. Bridgeports have a quill lock right here, which allows you to lock the quill in position, and in the unlocked position you can use it to drill holes. The quill has 5 inches of travel, and there is a quill stop right here that you can use for repetitive depths. This machine has a quick release quill handle that allows you to reposition it. I've shown this type of quill handle as well as this type of quill stop in my video on time savers for the milling machine, so I'm not going to go into them all that much. The stock handle is repositionable, but you have to actually pull the handle off and then reposition it. There's several holes on this ring right here that in this case all you have to do is move this out, it withdraws a pin, and then you can move it to another position. That's incredibly handy when you're drilling because you can put the handle where you've got the most amount of leverage. Likewise, this is an aftermarket quill stop, and this allows you to push this button and move the quill stop up and down very easily. The stock one you actually have to turn all the way up to position it, and there's actually a jam ring on there as well. Being as this is 20 threads per inch, that can take quite a long time to go from the bottom to the top and back down. These 4 bolts are what tightens the head when we're talking about tilting side to side. The 3 bolts back here allow you to tilt front to back. Then we have power down feed controls. This handle here actually engages or disengages the worm drive for the power down feed control. In general, you only want to have this handle engaged when you're going to use power down feed. Otherwise, it can lead to excessive wear on the head. The handle's actually in the engaged position right now, and all of the other controls are on this side of the head. This handle sets your feed rate in inches per revolution, and you've got 3 choices. You have 3 thousandths per revolution, 1.5 thousandths per revolution, and 6 thousandths per revolution. It's just like all of the other handles on the machine. You pull out this plunger and then you can reposition it to either of the other holes. This plunger controls whether you're feeding downwards or upwards. Normally you would also have the hand wheel here, and most people take that hand wheel off and stash it someplace because it's almost always in the way otherwise. To engage the plunger, you turn the machine on, and you'll either push it in to feed one way or pull it out to feed the other. You also have this handle which actually engages the power down feed. When you engage this, there's a whole bunch of stuff that goes on. You'll see this block slide over towards the scale, and that actually pushes a pin down, and there's a little lever down at the bottom that allows you to automatically disengage the power down feed with the quill stop. I'm going to set the quill stop a little higher so you can see that in action. You can see the quill's moving down, and when it hits the quill stop, it should disengage. Just like that. The head is actually connected by this knuckle here to the ram, and the ram can actually slide in and out, and it is sitting on top of what's called a turret, which is why sometimes these are called turret mills instead of knee mills. The turret allows you to turn the entire head one way or another, and you can actually spin it all the way around. On the back side of the ram, there's space for an accessory head, and Bridgeport actually made several different heads that could go back there. I mentioned before that you can make the ram slide in and out, and this is used when you have larger parts on the machine and you need just a little bit more reach, or if you turn the turret from side to side, a lot of times you need to move the ram out in order to actually reach the part that's on the table. So in order to move the ram, you loosen this bolt and the one over here just like it, and then you turn this handle, and there's a rack and pinion on the inside that allows it to move. Once you get it into position, don't forget to tighten up these bolts again. If you need to turn the turret, you loosen these two bolts and the two just like it on the other side of the machine, and then you actually can just spin the turret by hand. It actually does not take very much effort at all to move the turret, and because you can do this and you can move the ram, you can actually machine a part that's larger than the table. Most machines have degree markings here on the side so you can get it roughly straightened back up. There's usually no reason to check that the ram is straight to the machine because it's going to be locked down and you're never actually going to be machining with the ram handle. So as long as this is somewhere in the neighborhood of 0, you should be good. And again, don't forget to tighten the bolts. They also make riser blocks that go between the turret and the column of the machine, and those are usually in 4 or 7-inch lengths. What that would do is jack up the head so you have a little bit more room between the spindle and the table. Riser blocks are very handy if you do a lot of work on large workpieces. Imagine having, for instance, an engine block sitting on the machine here, and you've got the knee all the way down, and then you have the length of your cutter as well as the length of your tool holder in the spindle. You can run out of daylight very quickly between the tool and your part, and the riser block helps solve that problem. As far as the rest of the machine goes, you have the column of the machine, which is the main part of the casting, and the base down here. You have the knee, and a lot of machines have what's called a one-shot oiler, which is this guy right here. And this is a little pump. You fill it with the whey lube of your choice, and when you use this pump, it sends it up to a manifold and sends oil to all the points on the table. This does not oil the spindle, so you need to make sure to put oil in the oil cups that are on the head. As far as the table of the machine goes, that's pretty self-explanatory. You have a handle on either side of the table that controls your x-axis motion. You have a y-axis motion right here that moves in and out. And then you have a handle here that you can take off and remove for raising and lowering the knee. You also have locks for all three of these axes. Your x-axis lock is right here on the front of the machine. Your y-axis is right here, and your knee is right down here. You have a T-slot along the front that's used for setting up table stops, and there's a stop right here in the middle that allows you to do repetitive work. All of the machines at Parkland have a power feed on the x-axis, and this potentiometer right here in the front allows you to vary the feed rate. You can move the handle in either direction. And this button right here is a rapid traverse. So hitting that button actually moves the table as fast as the power feed will move it. The last thing I'm going to show you is the digital readout, and I'm showing this to you last because not every milling machine is going to have this exact readout or a readout at all. But I think you would be very hard-pressed to find a milling machine in industry that does not have a digital readout, because it is a massive productivity boost. In this case, it's a 2-axis digital readout, so we have X and Y. We don't have up and down, our Z-axis. The great thing about digital readouts is they show the actual position of the table of the machine. They are totally independent of the screw and the nut that drives the table, so they are unaffected by backlash. This means that if you were to zero the table right there and move away and then crank back over to 0, you will actually be at your original 0. Another great thing about digital readouts is the ability to easily switch between inches and millimeters. Aside from the 0 buttons, probably the most used button on here would be the half function. This allows you to zero on one side of your part, move over and find the edge on the other side of your part, and when you hit the half button and select your x-axis, it cuts the reading in half, and then you just need to move to 0 and you're in the middle of your part. Just like that. I mentioned that you can also put accessory heads on the back side of the RAM, and this is one type of them. Bridgeport actually made several different heads. This is called the shaper attachment or the slotting attachment, and you've got a variety of cutters that would go into the spindle here, and when you turn it on it reciprocates up and down. You can use these for cutting keyways in a bore, or gears potentially, or splines, or graduated dials. There's a variety of cutters that go in there, and of course you can make your own as well. I would turn this one on, except our switch is busted on it and we haven't gotten around to fixing it. You can change the length of the stroke on the slotting attachment anywhere from 1/8 of an inch all the way up to 4 inches. And you can also change it from 70 strokes per minute to 420 strokes per minute. When you're using one of these, you would actually loosen the turret and turn this around so that it's over the table. This is another one of Bridgeport's accessory heads that would be mounted onto the back of the RAM. This is their Model T cherrying head, which was used for die sinking. When you turn this handle, the spindle actually moves in a circular motion like this. You'll see this moving and this sliding back and forth. This is a little yoke arrangement. So when you turn this, everything moves around. You can see the yoke moving back and forth and the spindle moving up and down as well as side to side. You can change the radius of the rotation right here. It goes from anywhere from 0 to 1 3/4 inches. You have 5 spindle speeds, and it actually goes faster than the J head does on the step pulley version anyway, so it's not bad for high-speed milling. CNC machines have made these incredibly obsolete, so that's why you rarely ever see them. But with a little bit of creativity and a ball end mill, you can actually make some very complicated shapes. You can of course make a radius cut like that, but you can also move down 90 degrees, over, and then up 90 degrees. If you continually change the radius and step over, you can actually make tapered parts. The knuckle that attaches it to the RAM also has degree markings on it, so you can change the angle at which you're cutting your radius. Now, even though these are pretty rare, they're not very sought after, and you can actually pick these up pretty cheaply. I got this one for about $250. Granted, I got it very cheaply because it was missing a lot of parts that I had to replace. It was missing the hand wheel, this oiler was broken off in it, and it was missing the power switch, so I had to find a suitable one of those, which was also about $250. Now, I did buy this for a specific purpose, and I've actually never used it. I have very limited space here in my garage, and I can't actually turn the turret all the way around without moving the machine out from the wall, and that's a bit of a pain. I've actually got an original Bridgeport catalog from when my machine was new, which was 1963. So this actually shows all of the heads. It shows the shaper attachment, which is the Model E head, and over in the corner you can see some of the tools that are available. It's got all sorts of specs on there as well. On the left you can see the cherrying attachment, which is the Model T. I didn't mention, mine has a Morse 2 taper, so it'll carry an end mill up to a 1/2 inch. As options, you could get a number 7 Brown & Sharp taper or a B3 taper, which was Bridgeport's collet system. Now, I've never actually seen either of these two heads in person or on sale anywhere. So they have the Model R and the Model C milling heads, both relatively light duty, a 1/2 horse and a 1/4 horsepower. Now, neither of these heads actually had a quill. It was just a rigid spindle that didn't move up and down, so it was only for milling. They're both pretty limited in speeds. The Model C goes from 465 RPM up to 4250, and the Model R goes from 275 up to 4250. The Model R actually used R8 collets, which is pretty nice, whereas the Model C only used B3. Now, these are the two heads that you're most likely going to be familiar with. The Model J, also known as the J head, is what comes on most Bridgeports, and that's what I was talking about earlier in the video. They're showing the step pulley version here in the catalog. The M head is their original milling head. It takes a Morse taper, although there were options for the Brown & Sharp 7 and the B3. And you see these on a lot of older Bridgeports, especially the round ram versions. What was really interesting and possibly attractive to the machinists today is that the M head was available in 2 speeds. They had a low speed one, which is far more common. You've had 6 speeds from 275 RPM up to 4250, but they had a high speed version as well, with the low end being 950 RPM and the high end being 12,000. So you can imagine if you do a lot of small end mill work, especially in easy to machine materials, it would be pretty attractive to have that high speed M head. The M head also has a quill on it, so you can use it to drill holes, although the quill travels only 3.5 inches instead of 5 on the J head. I really hope you found this video helpful. If you have any questions, please feel free to put them down in the comments and I'll try to respond to them. Thanks for watching. I'll see you next time.